Okay, we're going to try to get through the last few slides very quickly, and I apologize if you hear a dog barking in the background. I'm working from home and my dog is being a little noisy, so please try to ignore that. Okay, going back to this example with the online time, I have a question for you now to think about. Let me just advance here. Oh, actually, one thing I wanted to mention before we move forward. We found that 151 was an outlier because we applied the 1.5 times IQR rule, but I wanted to make sure it was clear to everyone that even though 151 is an outlier, our 5-number summary is not changing. So 151 is still the maximum in the data set. We wouldn't suddenly say, because that's an outlier, it's no longer the maximum. So the 5-number summary doesn't change, but how you plot the data using a box plot will be modified a little bit if you know that you have an outlier in your data set. So now let me ask you a question. So for the online time example, let's say that you had to come up with the most appropriate measure of center, and this should not say spread, it should say variability. So sometimes we refer to variability as something called spread, but we're calling it variability now. What do you think would be the most appropriate measure in this case, the measures of center and spread? Or do you think maybe it wouldn't matter? Could you use anything? So you've learned so far about the median as a measure of center, you've learned about, and the mean as a measure of center, you've learned about the standard deviation and the IQR as measures of variability. Now we know that the distribution was skewed to the right. It was markedly skewed to the right, and we had an outlier way in the upper tail. So I would say, because of the fact that we have skewness and we have an outlier, the median and the IQR would be our best measures of center and variability. So why am I thinking that? Now again, when you're trying to describe a distribution in terms of center and variability, you have different options. We've seen different measures of center and different measures of variability. I always say compute everything, show your reader everything so that they can really see how different measures compare to each other, plot the data in different ways so they can see the data from different vantage points. The 5-number summary and specifically the median and the IQR are better if you have skewed distributions or outliers in your distribution. And in a second we'll talk about why that is. So if you plot the data, again, always begin with the plot, and you see some skewness, you see outliers, then consider reporting the median and the interquartile range. Now, if the distribution is symmetric and has no outliers, or it's fairly symmetric, it might not be perfectly symmetric, then the mean and the standard deviation might be your better options. I think that more people probably have an understanding of what it means when we say the mean or the average, and they might have heard about the standard deviation and understand that a little bit more compared to something like the interquartile range. Of course, if your distribution is fairly symmetric, then the mean and the median will likely be very close to each other, if not the same. So in that case, it really might not matter if you choose the mean and standard deviation versus the median and IQR. But definitely if you have skewness, consider reporting the median and the IQR. Now, why is that? Why would you want to report these other measures? Well, this relates to an idea called resistance. So we want you to have an understanding of which measures of center and variability are more resistant. Resistance means being resistant to outliers, not being impacted by outliers. So keep in mind, remember that when you want to compute the mean or the standard deviation, you use every single value in your data set to make those computations. Every single value goes into figuring out the average. Every single value goes into figuring out the standard deviation. So if you have any values that are outliers, either high outliers or low outliers, they will have an impact on the mean and the standard deviation. They will actually end up increasing those values. So the mean or decreasing them. So let me backtrack here. So if you have an outlier, the mean is always pulled in the direction of the outlier. So if you have a high outlier, the mean will be inflated. It'll be pulled in that direction. If you have a low outlier, the mean will be a bit lower. It'll be pulled toward the lower value. The standard deviation, that will increase if you have an outlier, because again, we're increasing the overall distance of data values from the mean when we have outliers. They're pulling the distribution in a particular direction, so that's going to increase the standard deviation. So an outlier either will increase or decrease the mean depending on where it is, but it will always increase the standard deviation. So because of that, the mean and the standard deviation are not resistant to outliers. Outliers have an impact on them. Now consider the median and the IQR. To find the median, you just go to what's in the middle of the distribution. To find the IQR, you're looking at the range of the middle 50% of your data. So what's in the tails is not going to have a really big impact on what is in the center of the distribution. So having a high outlier is not going to affect that value that's right in the middle of the distribution. And so the median and IQR tend to be more resistant to outliers because we don't need to use those outliers in the computations of those values. So that's why if you have outliers or you have skewness, think about reporting measures that wouldn't take those outliers into account. And that's where the median and the IQR come into play. Now, a few other quick things I just wanted to get through. This was an interesting article that I found not too long ago in the New York Times, and I thought it was interesting because they talk about Steubenville, Ohio, and they talk about the fact that, you know, if some very rich people moved to that town, like Oprah Winfrey and Warren Buffett, and we wanted to look at the average income of the town, the average would be a lot higher than what it should be because of the fact that we're taking into account these very large incomes. So the distribution would look something like this. Most people are down here, but then, you know, Oprah and Warren Buffett are way out here. They're pulling the average in that direction of the outlier. So it's going to look like people in that town earn a lot more than maybe they actually do. So there's a link here to the article if you want to go and read it. There's also kind of a nice NPR report that talks about means and medians and how sometimes means can be misleading if you don't really know the context or if there are outlying values in the data set. So means obviously can be misleading if outliers are involved in the computations. What about medians? Can medians be misleading? And here's a question for you to think about. What if upon a visit to a doctor you found out you had a disease where the median mortality rate is 8 months? What does that mean? The median mortality rate is 8 months. So this is based on an article. It was written by Stephen Jay Gould. Some of you may have heard about him. He was a famous biologist. He wrote a book about measuring intelligence. And he went to his doctor, and his doctor said, I'm sorry, you have this this form of cancer. It's very rare. The median mortality rate is 8 months. And being an academic, he wanted to know if he could read things about it. And the doctor said, well, there's really not a lot worth reading. This is how it is. And he didn't settle for that. He actually went and did some research to find out more about this cancer. And the whole point of his article is how hearing that term median can be misleading. A lot of people might think of that as being an average. They might not know how a median differs from a mean, how it differs from an average. And he soon learned that, you know, okay, the median mortality rate is 8 months. Obviously, the lowest that I could live would be 0 months. So there's going to be some data here, but the highest I can live can stretch out quite a while. So he determined pretty quickly that the distribution was skewed right. And he also determined that he had a lot of characteristics that were similar to the people who lived a lot longer than 8 months. So 50% of the individuals who have this cancer lived more than 8 months. And he actually went on to live, I think, 20 or 25 more years. And when he did pass away, it wasn't from this particular cancer. So the message in this article is that, you know, if you hear something about median, don't just assume that that means mean, or don't assume that that means average, and think really carefully about what the distribution would look like before you just give up all hope. So it's a really nice article. I hope that you'll take a look at it. Again, quickly, we've talked about this already, but just keep in mind that when you have a distribution that's skewed right, the mean will be greater than the median. The mean is pulled in the tail. If you have a distribution that's skewed to the left, the mean is less than the median. again, the mean is pulled toward the tail, toward the lower values. If you have something that's symmetric or fairly symmetric, the mean and median either might be exactly equal to each other or very close to each other. So again, plot your data. Look at how your data is structured. Look at what the distribution looks like, and think about how the measures are going to compare to each other, and which measure is likely going to be most misleading if you present that to your readers. So we don't want to mislead our readers. We want to give them a really accurate sense of what the data looks like and what the data is telling us. Quickly here, mean or median. So here's a quick test for you. What do you think you would report? Now, some of you might be landscape architecture majors at OSU. What is the mean salary for landscape architecture majors? So this department might decide they want to report the mean salary on their website. Let's say it turns out to be $64,180. Now, there was a former OSU student, some of you might have heard of him. His name is Eddie George, and he got a degree in landscape architecture. Obviously, though, he left OSU and wasn't actually practicing landscape architecture right away. He went on to do some other things. He went to play football. At the height of his career, he was making $7 million. So here's the question. What would happen if we included Eddie's salary in our calculation of the mean, and should we? You know, the landscape architecture department, maybe they want people to really want to come and study landscape architecture. They want to make it seem really cool and exciting, and this is something that you should study if you want to earn a fair amount of money. So perhaps they want to give a really high average salary. Well, if they want to do that, then maybe they want to include Eddie George's salary within their computation. But we know that's going to be misleading them, because we know the distribution would end up being skewed to the right. You know, Eddie's way out here. So we're misleading our consumers or our audience into thinking maybe something's going to happen that really isn't going to happen. So if we included Eddie's salary in our calculation of the median, if we included Eddie's salary in our calculation of the mean would increase. So again, the important point here is that when we compute the mean, every single value in the data set goes into computing that. And the mean can be inflated if we have a very high outlier like we would with Eddie George, or the mean can be deflated if we have a very low outlier. So the mean can be lower than maybe what it should be without that outlier included. Here, certainly if the department wanted to include Eddie George in their data set because he was a graduate of the program, then they could do that. But in that case, they might want to not report the mean, but they might want to report the median salary, because that would be a more accurate reflection of what students would actually earn with that degree, compared to including a student who obviously went on to do something that wasn't actually using that degree. I hope that this made sense. I feel like I was talking about things and they might not have made sense, but hopefully you get the picture here about which measure would be most appropriate to use and why. So finally, let's wrap this up. I know it's been a long set of lecture videos. I wanted to leave you with a question. So let's say we had two classes of students, Class A and Class B. So classes being college classes. And let's say each class is very small. It only has 11 students, and each class takes a quiz. It's the exact same quiz, and we compute the following summary statistics. So Class A and Class B, they both actually end up with the same mean and the same standard deviation. So I want to know, what do you think you can conclude about the distributions based on just knowing these summary statistics? What would you say? Do you think the distributions would be exactly the same because there are the same number of students and we have the same mean and the same standard deviation? So think about it. Let's say I threw this other information into the mix. Let's say I said, okay, well, look, we also have the median and we have the IQR for each distribution. So now you can see they're not exactly the same. And maybe you're noticing that in one distribution, the median is a little bit larger than the mean, and the other one it's a little bit smaller than the mean. Think about what that would tell us about skewness. So think about, would one of these distributions be skewed in one direction and the other skewed in another direction? It turns out that if you actually graph the data, you're going to see this. And here's the actual data, so you can see obviously that everything is not exactly identical in each data set. One data set is skewed to the left, one data set is skewed to the right. So the point I wanted to make here is that, again, Chapter 12 is all about summarizing data with numbers, about summary statistics. Statistics, again, are values that describe a sample. So just having those numbers is not enough. Just reporting to someone, here's what the mean is, here's what the median is, that's not enough, because that doesn't tell us the full picture of what's going on. So always, always, always graph your data, start off by creating the picture, and then go on to get more information to describe your distribution. Then go on to compute your summary statistics. Okay, so this wraps up Chapter 12. Again, I hope things are making sense. If not, please ask questions. We are always open to questions. We want to help you. And we will see you again when we get into Chapter 13. Thank you, everyone.